Hello friends, welcome to the channel. $250 billion. That's how much US operators are expected to invest to build 5G networks from 2020 to 2025. I know, that's a lot of money, but wait 1 second. That's how much it would take for you to download the next episode of your favorite series with your 5G phone. That's roughly 500 times faster than the first internet-enabled phone in the late 90s. Okay, but what is 5G anyway? Is it just about faster internet? Well, let's find out. In case you were wondering what that G in 5G stands for, that's for generation, because it is the fifth major iteration in broadband cellular network technology. There are three main application areas for 5G. You have enhanced mobile broadband, you have ultra-reliable low-latency communications, and you have massive machine-type communications. But don't get scared, these are just hyperbolic names that are used to refer to actually quite simple stuff. So what does enhanced mobile broadband mean? Well, actually it means faster internet connections and more capacity per tower. 5G towers will be able to support a much larger number of concurrent connections, which literally means more devices connected to the same antenna at the same time. This will be really useful in densely populated areas such as city centers, stadiums, and so on. But how much faster are we talking about? Well, chances are the phone you have in your pocket right now is a 4G phone. 4G download speeds with decent coverage average at around 20 to 40 megabits per second. How about 5G? Well, in an ideal lab environment, you can get up to 5 gigabits per second, which is roughly 100 times faster than 4G. But in a more realistic scenario though, you get up to 2 gigabits per second, which is still 50 times faster than 4G. Not bad, right? Yes, but there is a catch. 5G technology includes three bands. You have low band, you have mid band, and you have millimeter wave. Not all of three bands are supported by every antenna. In fact, crazy fast internet speeds are only possible if your device is connected to a millimeter wave tower. These towers are the only ones that support high frequency waves. High frequency waves do not travel long distance. In fact, they get blocked by practically everything. Walls, trees, even fog or rain. That is why you need to be really close, ideally in line of sight with the tower, in order to reach those speeds. Also, the fact that high-frequency waves do not travel that far implies that a much higher number of towers is required to cover a given area. That is the reason why most carriers are investing in lower frequency bands. These are still technically in the 5G spectrum, but allow for a much wider per tower coverage. This comes at the expense of speed though. In fact, mid-band 5G towers can deliver speeds in the range of hundreds of megabits per second, which is not wildly higher than 4G. Now let's talk about the second area of application. One of the promises of 5G is to enable the so-called ultra-reliable low-latency communications. Applications in this area range from process monitoring, robot control in the industrial sector, to remote diagnosis and remote surgery in the field of healthcare, to autonomous vehicle networks in the transportation sector. These are applications that require robust, uninterrupted, low-latency communication. You can think of latency as the time that is required for information to travel from your device to the tower, to its final destination and back. If you're a doctor performing remote surgery on a patient, it is fundamental that you have timely feedback as you operate. Thus, latency in such scenarios is crucial. 5G promises to deliver latency to the towers as low as 1 millisecond. But in real-world scenarios, 5G has shown to have latencies in the range of several tens of milliseconds. Actually, not much better than 4G. Plus, the latency from and to the tower is only a portion of the end-to-end latency. The reality is that if remote surgery will ever be a thing, it will most probably rely on wired optical fiber links rather than wireless technology. The third area of applications for 5G is the so-called massive machine type communications. This means being able to support an enormous amount of concurrently connected devices in a small area. This is considered to be an important building block of smart cities. We imagine a future in which our cities are populated by ubiquitous connected sensors. These sensors will be collecting data from streets, light poles, buildings, vehicles, and so on. Data will be used for traffic and parking control, air quality monitoring, and security surveillance. 5G infrastructure will be able to support up to 1 million connected devices per square kilometer. That is 10 times the amount that is currently supported by 4G tech. Okay, let's address the elephant in the room, shall we? Let's get to the question your little conspiracy theorists out there wonder to ask. Is 5G safe? Will it mutate your DNA and turn you into some sort of brainless zombie? I am so sorry to disappoint you, but no, 5G will do none of that. I've been asking myself why it is the case that so many people are concerned that 5G will harm their health. And I think I know a possible answer. Wireless technology is based on the transmission of electromagnetic waves through the air. This phenomenon is referred to as radiation. Now, people hear radiation and immediately they think about radioactivity and nuclear explosions. Now, it is true that high energy, high frequency radiation can potentially rip off electrons from atoms and potentially damage our DNA. Such kind of high frequency waves are called ionizing waves. But just to put this into perspective, high frequency 5G operates in the range of 50 GHz, whilst you need at least 30 million GHz in order to get into the ionizing area of the electromagnetic spectrum. That's the area of ultraviolet light. For this reason, there is a definite consensus in the scientific community that exposure to 5G frequency ranges is not dangerous for us. Okay, but hear this. Would you like me to tell you a source of ionizing radiation that you're very, very familiar with? The sun. Yes, the sun. Specifically, ultraviolet light. So last time you went to the beach, did you put the sunscreen on? Okay, so apparently 5G is not just about flicking through your Instagram feed at unprecedented speed. Or is it? Well, 5G seems promising, but so far it has been just that, a promise. The majority of carriers seem to be interested in investing in infrastructure mostly supporting mid-band 5G. That is because the cost per square kilometer covered is much more convenient. Millimeter wave towers that are required to support higher speeds are in fact very sporadic. And if we look at other areas of application, like self-driving vehicle networks or hyper-connected smart cities, these are not coming anytime soon. Standards are just being defined or are still under definition. If that's what you were waiting for, you might be deluded, since we are still years away from those. Okay, that is all for today. I'm Francesco Fusco and this is Decode, the only place in the world where we take reality and decode it for you, so you don't have to do it on your own. If you found this useful, stick around and subscribe for more content. Feedback is always welcomed, so please leave a comment below if you like. Thanks so much for watching. See you guys in the next one. Cheers.